Good day, mammals. This is going to be the first part in a two-part video on scientific notation. We're just going to cover the conversion between decimal and scientific notation in this video. In the second part, we'll be doing math with scientific notation. The integrated 2 guys, you will see this on your sheet as topic 4A. So let's get started. So we're going to have a lot of practical uses for scientific notation in both the integrated 2 and the chemistry classes, because we'll be talking about numbers that are incredibly big and numbers that are incredibly small. For instance, if we're dealing with number of atoms, because atoms are so tiny, the number of atoms is going to be huge. Like there's a number that we'll be using a lot to express the number of atoms, and it's a 6, a 0, a 2, and a 2 with 20 more zeros behind that, and no one wants to have to sit down and count out 20 more zeros. So it's a lot easier to express large numbers like that using scientific notation. And if we're talking about, say, the charge on a proton or an electron, that's going to be the other end. It's going to be a very, very small number, so we're going to have to use scientific notation to express that. And when we're converting from decimal notation to scientific notation, what we're looking for proper scientific notation is we're going to take the decimal from wherever its present location is and move it until we have only one digit in front of it. And that digit can't be a 0, it has to be a 1 to a 9. And then we're going to add a times 10 with an exponent to indicate how many places and in which direction we move the decimal. If we made the original decimal number smaller, then the exponent needs to get larger to balance that out. And if we made the original decimal number bigger, then our exponent is going to need to get smaller, i.e. negative, to indicate the direction that we move that. So we'll get started off with some examples here. Now in this first one, 1500, there's no decimal place shown, but everybody knows where it would be. It would be right there at the end of the number. So I need to move that decimal place until there's only one digit in front of it, and that would be moving it 3 places over. So that is going to become 1.5 times 10 to the third. Okay, similarly here, this one's maybe a little bit easier because the decimal is shown, and we need to move it 2 places so that there's only one number in front of it. So I'm going to rewrite this as 1.01306 times 10 to the 2. Okay. On this one, decimal is shown. I need to move it actually to the right to get one non-zero in front of it. Now sometimes students stop here in front of this first 5, but remember that first digit can't be a 0, so we're going to need to move it one more place, and so I actually need to move it 1, 2, 3, 4 places over, and I'll rewrite that as this. Now we move the decimal in the opposite direction. This number 5.52 is bigger than the original number, so my exponent needs to get smaller, so it needs to be negative 4 because I moved the exponent 4 places to the right. Okay, now this one's kind of a tricky one here, but we'll write it. I mean, there isn't a practical reason why you would write this in scientific notation because we don't need to move the decimal at all. There's one digit in front of it, but I'm just putting that out there as kind of a trick question. Since we didn't need to move the decimal, it's going to be times 10 to the 0. A lot of students would make the mistake of saying times 10 to the 1, but that's not right because 10 to the 1 is 10, and 5 times 10 to the first power is 50, and so that's not the same as what we had. So it's actually 5 times 10 to the 0 because any number to the 0 power is 1. Okay, this one's sort of like this guy right here. We're going to need to move the decimal to the left, and we're going to need to move it over 2 spaces so that we have only one number in front of it, times 10 to the negative 2. This one is kind of like our first one. No decimal is shown, but if it was shown, it would be right there. And I need to move it such that it's between the 1 and the 6. And I had to move that 4 places in the positive direction to get that. And lastly here, it's my birthday. So this would get turned into, only needed to move that 1 space, so times 10 to the first. Okay, and that's some examples of converting decimal notation to scientific notation. Now let's go backward. Okay, so on this slide I have scientific notation, and we're just going to work this process backwards. So here I have a positive exponent, so that tells me that I made the original number was bigger by 1 power of 10, so I'm going to work this backwards, and that is going to become 26.5. Okay. Here we have a negative exponent, so that tells me the original number was smaller than this number by 5 powers of 10. Now don't get lazy. A lot of students see that -5 and they know it's negative, so they're going to be putting zeros in front of it, and they'll just get lazy and they'll put 5 zeros out in front of it. But there's only going to be 4, because the first power of 10 is just getting you in front of that 1. So it's going to be 0.000, 4 zeros, 1, 8, 5, 9. Okay, this one, positive exponent, so this number was larger than the number shown here by 6 powers of 10. So I'm going to do, that's 1 power of 10, 2 powers of 10, 3 powers of 10, and I have 3 powers of 10 left over, so that's just going to be 3 placeholder zeros there. Okay, here we need to make this one larger by 3 powers of 10. So move it 1 space, that's my first power of 10, my second power of 10, my third power of 10, decimal point, 3. So I move that decimal place 3 powers of 10. And lastly here, I've got to make this one smaller by 6 powers of 10. Again, the first one is just getting it out in front of that 2. And so that means I need 5 zeros, 2, 7, 5, 3. Okay, and that's some examples going the opposite direction from scientific notation back to decimal notation. That's where we're going to stop this segment of the video. The next part will be doing some math with scientific notation. All right, guys.